Hello everyone. Hope you are doing well. I am Akshay Parmar, Assistant Professor at LJ Institute of Engineering and Technology in IT ICT department. Welcome to the video tutorial series of the data communication and the computer networks. Right? Today we will discuss multiple access link and its type taking turn protocols. Right? So let's see in brief. First of all, let's discuss about today's outline of this video. In this, we will discuss multiple access links and its type. The taking turn protocol, right? So when one carrier and more than one station is there, who will be first access will be decided by the control access tree, right? All the station consult all the stations, right, to find out which station has the right to send. For that we are using a different kind of techniques. The techniques are reservation, polling, and the token passing, right? So let's discuss about its one type, the taking turn protocols, right? So node takes turn, but nodes with more to send can take a longer turn, right? So that's the fundamental about the taking turn protocol. Example of the taking turns protocols are polling and the token passing, right? So first of all, let's discuss reservation, right? So in this techniques, what are this method? In this method, a station needs to make reservation before sending the data. In this method, a station need to make reservation before sending the data, right? If one station want to send the data in this channel, that station needs to reserve that slot, right? So let's have an example by that, right? So if suppose we have the 5 station who want to send the data, right? So this is the stack for that. This is a mini slot for the that reservation quota, where the number 1, 2, 3, 4 and 5 are the stations number, and this is the mini slot by which they can make a reservation for sending the data. Let's take an example. The station 1, 2 and 5 wants to send the data, so they are reserving their slots by putting 1 in that mini slots, right? The station number 1, 2 and 5 have reserved that slot by simply putting 1 in that particular mini slot, right? The rest of the station who don't want to participate in the sending data, we are putting the 0 in that mini slot, right? So in this method, a station need to make a reservation before sending the data. So the station number 1, 2 and 5 has reserved their mini slots. The station number 1, 2 and 5 has reserved their mini slot by putting 1 in respective mini slot, right? By that, the data slot 1 is sending the data, right, with respect to they have the reserved the slot for that. Likewise, data slot 2 and data slot 5 are corresponds with that mini slot in which we have reserved the slot for that. The rest of the station can't send the data because they doesn't have reserved its slot, right? So that's how the reservation technique is working. If there are n station in the system, there are exactly n reservation frames, right? So as you can see in the figure there, we have the 5 mini slots there, so maximum 5 station can send and receive the data with the reservation technique, right? So that's all about the reservation technique. After that, let's see the polling, right? So what do you mean by the polling, right? So it requires one of the nodes to be designated node as a master node. We can say that is a primary node also, right? So all other nodes are a slave node or a secondary node, right? After that, the master node or the primary node polls each of the nodes in the round robin fashion, right? The master node first sends the message to the node 1, right, saying that you can transmit up to the maximum number of the frame, right? So the primary node sends a message to the node 1, the first node, and asking about that if you want to send the data, right? So if they want to send the data, then they have the maximum number of the frame assigned, right? They can transmit up to some maximum number of the frame, right? After the node 1 transmits some frames, right, the master node tells node 2 that you can transmit the data up to the maximum number of the frames, right? So after completing After completing the sending of the data by the node 1, we are taking the access from the node 1 and giving them to the node 2 and asking the node 2 about if you want to send the data. If that node want to send the data, we are giving them to transmit the data about up to some maximum number of the frame which is decided by that system, right? The master node can determine when node has finished the sending and its frames by observing the lag of the signal on the channel, right? So that's how the primary node or the master node is determining about when the node has finished its sending the data. That's how the polling is working. The procedure continue in the manner with the master node polling each of the node in the cyclic manner. As we have discussed, it is sending the data in the round robin manner, right? So the polling each of the nodes in the cyclic manner, as you can observe in the figure there. We have the node 1, node 2, and so on, right? So master node is asking about that. Okay, node 1 want to transmit the data. That node 1 is transmitting the data about some maximum amount of the frame. After that, the master node will ask the node 2 about if you want to send the data. After that, that access is taken from the node 1 and given to the node 2. After that, that node 2 is transmitting the data about some maximum number of the frame, right? So that's how the nodes are sending the data in the channel, right? So that's about the master slave or the polling system. The polling protocol estimate the collision and empty slots, then slave random access protocol, right? So by the help of the master slave or the polling protocol, we are eliminating the collision, right? They have the two various functions, right? So polling work with the topology, as we all discussed, right? So in this, one device designated as a primary station or a master, and other device are secondary station or the slave station, right? So all the data actions must be made through the primary station or the master node, right? It controls the ring, right? It controls the link there. The master node controls the link there, right? The two functions are mainly used with the polling. The first one is a select function, and second one is a polling function. Let's see how the select function is working. So in that, we have the primary station and we have the node A and node B. If the primary station want to send the data to the node B, so how that data is sent, right? So for that, the select function is that the primary station will send the select signal to the node B, right? So that's how the select function is, the select signal is sent from the primary station to the node B. If the node B is acknowledged about it is received the data, so the node B will acknowledge about it has received the select signal, right? After getting the acknowledgement from the node B, the primary station will send the data right after that, right? So after getting the acknowledgement, the primary station will sending the data. By that, it is confirming about the node B is receiving the signals from the primary signal, right? After receiving the data, the node B is sending the acknowledgement about it has received the data, right? So that's how the select function is working. In that, the primary station is selecting a node, and after getting the acknowledgement by that node, it is sending the data. That select signal is sending all of the network, right? So for the all of the node. After that, the destination node will acknowledge about it has get the signal selected, right? And after that, the data transmission is starting. So that's how the select function is working. The second function is the polling function. In that, whenever the primary signal will receive the data, how it will be received? So in that, the primary signal will send the poll to each of the node. By that poll, it is asking about if you want to send the data, right? So if the node don't want to send the data, it will giving the negative acknowledgement to the primary station, right? So in our case, the node A don't want to send the data to the primary station. So after getting that polling signal, the node A will sending the negative acknowledgement about it don't want to send the data in the channel, right? The node A don't want to participate in the transmission of the data, right? After getting the negative acknowledgement from the node A, the primary station will send the polling signal to the node B, right? So here, if the node B want to send the data to the primary station, so after getting the poll from the primary station, the node B will simply send the data about what it will be want to send, right? After getting the data from the node B, the primary station will sending the acknowledgement about it has get the data from the node B, right? So that's how the polling function is working here. So in that function, the primary station is asking the node about if you want to send the data. If they don't want to send the data, they are simply sending the negative acknowledgement about that signal. And if they want to send the data, right, so they are sending the data after getting the polling signal, right? That's how the polling function is working. So that's all about the select function and the polling function in the polling. Alright, after that the token passing is there. So the another type is token passing. So there are no master node in this particular system, right? So in that, a small special purpose frames known as the token is exchanged among the all the nodes in the some fixed order. It can be clockwise or anti-clockwise, right? So a small special purpose frame known as a token is exchanged among all of the nodes in some fixed order, right? For an example, node 1 might always send the token to the node 2. Node 2 might always send the token to the node 3. The node 3 will send the token to the node 4 and so on, right? Node n might be always send the token to the node 1, right? So that's how the particular some fixed order they are transferring that token from one node to the another node, right? After that, when a node receives a token, it holds onto the token only if it has some frames to transmit, right? Otherwise, it immediately forward that token to the next node, right? So let's see an example. If node 1 is sending the token to the node 2, if node 1 want to transmit that data, they will send the frames to transmit, right? But if the node 2 don't want to transmit the data, right, so it will simply transmit that received token to the next node, right? So that's how the token is exchanging among the all the nodes in the fixed order. If failure of the one node can crash the entire channel, right? Or if the node is accidentally neglect to realize the token, so this is the disadvantages about the token passing, right? So if the one node is crashed, it can be crashed the entire system, because every node is sending the token one by one to the each of the node. In the middle of the system or middle of the architecture, if one node is crashing, so the passing of the token will be stopped there. The for further nodes cannot get the token from the previous node, right? So this is the major disadvantage about the token passing. After that, let's see the Ethernet. So what do you mean by the Ethernet? Ethernet is one of the widely used local area network LAN technology, right? It has mainly three types. Let's discuss about switch Ethernet, right? So in that, it gives the dedicated 10 Mbps bandwidth on each of the port, right? On each of the ports, one can connect either a thick Ethernet or the thin Internet, right? Or a thick or thin segment or a computer. The second part is the fast Ethernet. So what do you mean by the fast Ethernet? The 802.802.u or the fast Ethernet was approved by IEEE 802 committee, right? It uses the same frame format, same as the CSMA CD protocol, and the same interface as the 802.3, but uses the data transfer rate of the 100 Mbps instead of the 10 Mbps which is having in the switch Ethernet, right? So in the fast Ethernet, we are getting the higher speed up to 100 Mbps, right? The fast Ethernet is based entirely on the 10 base T, right? So that's about the fast Ethernet and the thin Ethernet, right? So let's discuss about the Gigabit Ethernet. The Gigabit Ethernet is carried primarily on the fiber optics, right? So with the very short distance possible on the copper media. The Gigabit Ethernet carries primarily on the optical fiber, right? The fiber optics were used while we are working with the Gigabit Ethernet. The existing Ethernet LAN with the 10 and 100 Mbps cards can feed onto the Gigabit Ethernet backbone, right? So as an alternative technology that competes the Gigabit Ethernet and is ATM, a newer standard 10 Gigabit Ethernet is also becoming available nowadays, right? So the new standard 10 Gigabit Ethernet is also became available. For an example, 100 base T, 10 base T, and all that, right? After that, let's discuss about the bit stuffing. So what the system is working in the bit stuffing? In the bit oriented protocol, the data to send is a series of the bit, right? So in order to distinguish frame, most protocol uses the bit pattern of the 8-bit line, right? So for an example, 0 1 1 1 1 1 1 1 0, right, as a flag at the beginning and the end of the frame. Here you can observe that we have 2 0 and the 6 1 in that pattern, right? After that, here also poses the problem of appearance of the flag in the data part to deal with this extra bit added, right? So in that this method is called the bit stuffing. In that, if the 0 and the 5 successive 1 bits are encountered, an extra 0 is added. Here in our example, we have 0 666 0, right? So in that the 0 and the 5 successive 0 are encountered, then we are simply put an extra 0 there, right? And the receiver node will remove that extra added 0 and get the actual data which is sent by the sender or which is transmitted by the transmitter, right? So let's see by one example. This is our bit sequence 0 1 1 0, and after that the series of the 1 there, right? So in that we are simply adding that extra 0 after the successive of that, right? So we have the 0 and the series of the 1 there. So after each 5 1 we are simply stuff bit 0 in that, right? So our new bit sequence is this like, right? So in that we are simply stuffing the bit 0 after the 5 iterative 1, right? So this is about the stuffing, bit stuffing, right? The added extra additional added 0 are the stuff bit, right? So by that we are getting that sequence, right? After receiving that bit sequence at the receiver end, we are simply discard the extra added 0 and get the actual data which is sent by the sender, right? So this the adding the 0, adding the stop bit at the sender side and removing the stop bit at the sender receiver side is adding the extra stop bit at the sender side and removing that stop bit at the receiver side is happening, right, in the bit stuffing. After that, let's discuss about the byte stuffing. So the problem of resynchronization by having each frame start and end with the special byte. A flag byte is used to separate the frame as both at the starting and the ending delimiter, right? This technique is called byte stuffing or the character stuffing, right? In this way, if the receiver ever loses synchronization, it can just search for the flag bit and flag byte to find the end of the current frame, right? Two consecutive flag bytes indicates the end of the one frame and the start of the next one, right? So the two consecutive flag bytes indicates the end of the one frame and the start of the next one, right? So let's see the byte stuffing example. To solve this problem is to have the sender's data link layers insert a special escape byte just before the each accidental flag byte in the data, right? So the data link layer on the receiving end removes the escape byte before the data are given to the network layer, right? So in our example, this is our data, right? Where the two flags, the flag is put in the starting and the end of the data, right? The payload data is there. Before that we have put a header, and after that we have adding the trailer. And before header and after the trailer, we are simply putting the flag, right? So after that, the ARP protocol, the address resolution protocol. So what do you mean by that address resolution protocol? It is a protocol for mapping an internet protocol address to the physical machine address that recognize that in the local network, right? It is a protocol for the mapping an internet protocol address, IP address, to a physical machine address that is recognized in the local network, right? So for an example, in the IPv4, an address is 32-bit long, right? The physical machine address is also known as a MAC address, right? A media access control, or the MAC address. The table, usually called the ARP cache, is used to maintain a correlation between each MAC address and the corresponding IP address. So for that, the ARP resolution protocol is there. The ARP provides the protocol rules for making this correlation and providing address conversion in the both direction, right? So that's the major part of the ARP protocol. So how the ARP is working? When an incoming packet arrives at the gateway asks the ARP program to find the physical host or the MAC address that matches the IP address, right? After that, the ARP program look in the ARP cache, and if it finds the address, provided it so that the packet can be converted to the right packet length and format and sent to the machine, right? If no entry is found for the IP address, the ARP broadcast is requested packet in the special format to the all the machine on the LAN to see. If one machine knows that it has that IP address associated with it, right? So if it don't, or if it doesn't found that IP address, the ARP simply broadcasts the request packet in the special format to all of the machine on the LAN. A machine that recognizes the IP address as its own returns a reply, right? So that's how the ARP protocol is working. ARP updates the ARP cache for the further reference and then sends the packet to the MAC address that reply, right? So that's how the ARP protocol is working. So this is the example. If it doesn't find an IP address with linkage with the MAC protocol, it simply broadcasts the data about do you have that IP address. If one of the signal is sending the data, is replying the data, the physical address or MAC address with linkage with that IP address, the system is getting that, right? So that's how the ARP is working. In this session, we have seen the media access protocol. After that, we have seen the turnaround protocol there, right? So that's all about the today's session. Thank you for the watching.